Hello, welcome back for the presentation of CYME software. In this presentation, we would like to model very simple network. But first, I just again want to describe customization. We need to have the minimum explorer bar, what we require already. Okay, go to toolbar, the minimum toolbar that we need already. And what we need, again, we have to go to preferences, and for this item, displays section property dialog. When adding a section or a device, we have to click on no. For configuration, user interface mode, we have to click on balance. It's unbalanced or unbalanced. Okay. Units, it should be SI. Default unit or load type should be kilowatt and power factor, and that's it. Then I go to file, click on new study, and then click on, for example, 3 buses, 0, 1. Okay, then I go to view property. What is important here, we want to have a nice graph, so we need alignment. Click on show alignment lines when moving elements, and yes. And region selection handles should be yes. Enable automatic region selection should be yes. Okay, and that's it. Okay, and you know that we already customized the symbol bar. What we need exactly, we put it in symbol bar. So right now we want to draw a network. Very simple. Click on bus bar, second bus bar, extend second bus bar, third bus bar, and connect the source, put a transformer, 2-winding transformer. Okay, then connect the cable, and then connect the load and induction motor. Then I want to create database. For source, I create a database, 33 kilovolt. So nominal voltage and operating voltage, I put it 33. Rating, it will be 60. And source equivalent impedance, I click on calculate. Short circuit data for 3-phase 900, for single phase 200, and X over R is 10. So when I click on OK, you can see source equivalent impedance based on ohm or per unit. Then I go to transformer. I want to create a transformer, 33 by 6 kilovolt, 15 MVA. So I have to fill this data. Transformer type, 3-phase shell type. Okay, insulation type liquid. Nominal rating 15,000 kilovolt ampere. Primary voltage 33 and secondary voltage 6, and no load losses 150 kilowatt. Click on sequence impedance to have a default value of impedance. Configuration delta YG and phase shift DY N11. Click on OK. Then I go to motor, induction motor, and create a database. I can import it from CYME database. So what I need, I go to 6.3, 6.6 kilovolt, 2346 HP. I use it, but it is 6.6. I need a 6 kilovolt motor. Okay, I rename it, right click and rename it, put it 6 kilovolt and 2000 kilowatt. Just change the value 2000, voltage 6 kilovolt. I don't change the power efficiency and power factor. Go to subtransient impedance, compute from the lag rotor data. So lag rotor power factor is 20%, NEMA code is F, okay, and short circuit or starting current, it will be 6 times. Then go to equivalent circuit. For equivalent circuit, I want to estimate equivalent parameters of the motor. Cage factor, put it 0. We don't want to be involved in cage factor calculation. Then select the method, estimation method, lag rotor and full load test. Click on estimate. Sleep is 0.01. Parameter automatically came, and click on estimate. When you click on OK, the model has been calculated already. Then click on OK. I have motor. Then go to cable. I import one of the CYME cables, 7.2 kilovolt. I think 400 kilovolt, copper, 1 core, XLP and armor is enough. I have it, that's it. Then I go to load, and load I put it 500 kilowatt and 80% power factor. Okay, right now I want to relate the data. Let's go to source, relate the database to the equipment. For transformer, I go and select it so all the data automatically come. Again, for the motor, okay, for induction motor, again, let me check it. Oh my God. Okay, I create it again. I click on cancel. So it will be a motor 6 kilovolt, 2000 kilowatt. Again, I have to calculate it from 0, 2000. Then efficiency 93, voltage 6, and power factor 91, speed 1500. And again, go to this 20%. NEMA code should be F 6 times. A short circuit starting current. And these parameters, I put it 0. Estimate, use the estimate method of CYME. That's it. I go to motor and select the data. Automatically the data came. And for cable, relate the database and length of cable 500. That's it. Now I save it. Go to File, Save Study As, and save it as 3 bus bar 001. Okay. Then I want to do something else. I want to customize the tags. So because we prepare the template tags, I just want to import it. Don't want to be involved in customizing the tag. So I go to View, Tags and Text, Customize. Then click on Import, and there is a basic industrial tag. Open, import it. That's it. So you have all the tags. Right now I want to see input data tags. Okay, input data. This input data tag do not include transformer. I want to click on transformer. You can see also the transformer. So right now you can see input data for all the equipment. for bus bars, for loads, for sources, and transform. You can see we have two type of input data number 1, okay, see, into input data number 2, okay. For all the equipment we have two type of data right now, input data number 1, input data number 2. Okay, so we have input data, we check the data if they are correct. Then we want to go to load flow. Click on load flow, Newton-Raphson tolerance 0001. Then go to output and I need, for example, abnormal condition to see the abnormal condition, or for example, summary report is enough for me for now. Summary report and one line diagram result tag. I select power flow 001 and run it. When you run it, let me remove these two. You can see the voltages, the current, the power for all the equipment. We have three types of tags for power flow. You can change it. This is type power flow 002, power flow 003. So you can have three types, and in three format you can see the parameters of power flow. Okay. So right now I want to do short circuit. So first want to do short circuit for this bus bar. Right click, apply fault IC, and select calculation mode as a fault flow, current and voltage. Okay, and select all types. When you go to output, you need to select the report. The report could be faulted bus summary and first ring. Then one line diagram result tag should select as a fault flow 01. Save it and run it. When you run it, you can see, let me close this. You can see the short circuit current on this bus bar and contribution from motor and other bus bar, the network, and also the unbalanced voltage of other bus bar. And then I can change line to line. You can see the voltage. Fault type I'm changing. Line to ground. 3-phase and 3-phase to ground. Okay. Also, if I go to report, there's a nice report about the current, faulted buses, summary report about the impedances, Thevenin impedances, 3-phase, 2-phase, first impedances, everything very nice in the summary report. And also in first link branch, you can see all the contribution for all the phases. Okay, I remove this. Right now I want to do short circuit for all the bus bars, not only for one bus bar. Click on run. Select calculation method at the short circuit level and at all buses and nodes. Okay, go to output and then select report detail and summary. So we will have detail and summary. And then for one line diagram result tag, select buses short circuit current, buses short circuit current level, and run it. So right now in this case you can see for each bus bar you are able to see the short circuit current of 3-phase, 1-phase, 2-phase, 2-phase to ground, and short circuit power as well. Okay, so for all the bus bar you can see this short circuit. Also for the summary report, there's a nice summary report. Minimum, maximum fault for the network, and also detail of short circuit current. Also in this case we can do something else. If you go to duty type, I can select an all duty type. When I select on all duty type and I run it, save it, let me see. Let me change it. You can see I can show breaking, initial, breaking, peak current, okay, and steady state current on one line diagram. So in this case, you have all the duty types and all the phases short circuit current in one shot. Right now, I want to do motor starting. So select dynamic motor starting. Okay, select the motor, and then I run the case. First, there is no assistant. I have to change the status from running to starting. Then click on run, and I can see voltage, current, and torque of this motor. Okay, current and torque. Then I want to do another study. I want to have a VFD. So double click on the motor, select starting assistant and go to VFD, and for example controllable current for starting is 1.2 of rated power. Then I run it again, and I can have a curve in new view, but right now I want to compare it with previous one. So I select previous one and click on voltage. Again, select previous one for current and click on current plot. Again, select previous one for the torque and select torque and click on plot. Then I go to curves tab, and you can see, for example, this is for voltage. To be more clear, I right click, click on setting, go to curves, and change color of the curves. See? So the blue ones is direct online, and red one is the curve with VFD. And also I can have markers. Click on curves, select lines and markers, then again come back to the curve. This curve is blue, so I select marker as red. The second curve is in red, so I select marker and blue and click on apply. So you can see a nice shape. I can zoom, double click and draw, and again double click, and you can also click, you have a right click, go to Y axis unit and have it as a per unit. So you can have this as a per unit. Okay, let's do another case. Go to Windows, close all charts. I want to have a VFD as external device, not as only as a starter. So again, go to Explorer bar. I put a VFD here. Then I need a cable, drag and drop cable. Just extend this a bit. Okay, when I extend this, change the. Okay, so right now I have a cable. Double click on the cable. Again, go to the cable ID and refer the database. Put length of this cable 500, so I can calculate voltage drop after VFD, and this motor will be started with VFD. But first I have to go to power electronic, VFD, and create a database. So it should be 2000 kilowatts, 6 kilovolt. Okay, voltage should be 6 kilovolt. The current will be around 500 the maximum current, and then rated power is 2000 kilowatt. That's it. I select VFD and refer the database, and the output frequency is 50. That's it. So first I do load flow. I run the case, and you can see the power. I go to view, Explorer bar, result box. I keep the data for this motor, not be changed in the next running. Right now I want to change the frequency of this motor, make it 25, okay, and run the case again. So you can see the power in frequency of 25 is 1000, but here we kept it, the power here is around 2100. So when the motor operates in half frequency, it will ask for half power. So this VFD is as a starting assistance and also frequency control or speed control as well. I make it again as a 50 Hz. Remove this and go to dynamic motor starting and click on run. Right now it's running with VFD and external VFD. Okay, and in this case the drop after VFD on the cable has been calculated. I click on voltage and click on current and click on torque and speed vs time. That's okay. Okay, what else I want to do is that I want to change the frequency of this VFD. I click in 25 Hz and then again run the analysis. So I click on 25 Hz and again start the motor, and for the voltage I select on destination previous calculation for the, that's it, and for the, I think for the speed vs time, I go to speed. You can see right now I reduce the frequency. Right now you can see that this motor, when I reduce the frequency of the VFD, is running at half frequency. So this VFD control the frequency, and motor will be start up to the frequency of the VFD that is already controlled. Let me go to again. I go to voltage. So this is voltage and this is speed vs time. Thank you for your time and hope to see you in the next presentation. Thank you and bye.